Hey everybody, it's Mr. Jones. I know you're probably stressing out because you've seen all the labs popping up on our Google Classroom and you're wondering, how can you do a lab if you're stuck at home? Some of the labs we can't do at home, so I'm going to do them for you. I have all the things that we need because of the science school bus. So let's attack how constant is volume. We'll start with the problem. Here's what we're trying to solve. Will the volume of a piece of clay change if we change its shape? The purpose of this lab is to determine if the volume of a piece of clay will change if the shape of the clay is changed. We will determine this by using the method of finding the volume of water displacement. This method is useful when the volume of an odd-shaped object is needed, allowing us to determine if the changing of the shape of clay will change its volume. Archimedes first discovered this method when he was asked to find the volume of the king's crown. This lab is going to help us to determine how volume and shape are related. Using this method, we can determine if food storage containers of different shapes hold the same volume or not. This is going to help us when we go to put leftovers away in plastic containers. It's also going to help us as consumers. As consumers, we must constantly choose between different brands. Manufacturers may use different shapes of containers for their products just to make them appear larger. This would increase our likelihood of buying that brand over others. If we know how volume or shape are related, we can be more educated consumers. So, your hypothesis is your educated guess. After completing this research, what is the best answer to our problem? Remember the problem. Will a volume of a piece of clay change if its shape is changed? Our hypothesis, after completing the research, what is the best answer to the problem? You can record your educated guess, and then you're going to record also the reason why you guessed or you answered the way you did. Now, before we get started, we're going to look at the experimental procedures and make sure we have the materials we need. We've got graduated cylinders, so we've got that. We've got water. I added blue food coloring to it so it makes it easier for you to read the volumes. And we've got clay. So we've got all the materials we need. So let's start with the procedure. Read all directions first. We've done that, so we're good to go. Get all the materials. We have everything right here. Test 1. Fill the graduated cylinder with 50 milliliters of water. You can't see it from there, but these graduated cylinders have marks from all the way at the bottom of 10 milliliters all the way up to 100. So we're going to be very careful. I'm going to do 2 at a time so that we can move a little quicker in this lab. I know you're going to get bored if it's 30 minutes long. I'm going to be as accurate and precise as I can. So I filled both these graduated cylinders with exactly 50 milliliters of water. Let's take a look. So now that we've got a graduated cylinder filled with 50 milliliters of water, we need to record this value in our data table. So you're going to write that down under data table 1, trial 1, volume of water in milliliters. When you do so, make sure you always also record your units. Don't just write 50. You have to write 50 milliliters or ml, or your values are not correct. Step 5 says mold the clay into the shape of a cylinder. So I'll take our little piece of clay here and I will turn it into a cylinder. So now we've got a cylinder. Step 6. Slowly lower the clay into the graduated cylinder. You don't want to drop it in because you can splash stuff out if you do so. And although this is water, so it's safe, if you're doing an experiment with acid or something and you splash it on you or your neighbor, people aren't going to be happy. So you got to follow the safety rules as well. So we've lowered the clay into the graduated cylinder. Now we need to read the new volume level, the new water level. So let's take a look at that. So for test 1, volume of water in clay 1, we'll zoom in here and you can see we've got the big line at 60 and then we're 1, 2, 3 up. So this has 63 milliliters. So we saw that the water has gone up to 63 milliliters. You're going to record that in trial number 1, volume of water and clay, 63 milliliters. Find the volume of clay by subtracting first the water level from the new one. So we have 63 minus 50, which gives us 13 milliliters. So in trial 1, our clay cylinder has a volume of 13 milliliters. Step 9, take the clay out and empty the graduated cylinder. I'll pour it back in our bucket of water and get our clay out. We've got our clay now. And then it says repeat steps 3 through 9 2 more times. I pre-filled this graduated cylinder with exactly 50 milliliters of water. So we're just going to do the same thing. We're going to record that volume in trial 2, volume of water, 50 milliliters, because that's what we use. We're going to lower it down into here. We are going to measure our second volume. So our value for trial number 2, volume of clay and water, is the same as the first trial, 63 milliliters. Volume of water, trial 3. We are at 50 milliliters. We are going to now slide our clay in. Here it goes. And let's see where we ended up. There's our 60 line again. 1, 2, 3. So we started with 50, we're at 63 again. So now that we've measured trial 3, we can record our values in our data table. Remember, we started with 50 milliliters of water. We put our clay in. The volume rose to 63. 63 minus 50 leaves us with a total of 13 milliliters. Now you're going to take the total of those, 13 times 3, or 39. And then the average, you're going to take the total divided by the number of steps we did. So you're going to have 39 milliliters divided by 3 trials, which leaves us a volume of 13 milliliters in trial data table 1. Now that we've done all the steps for test 1 and recorded everything on our data table, let's move on to test 2. Test 2 starts out, fill the graduated cylinder and record the volume as you did before. So we're going to go ahead and fill these both up again, just so it makes it a little quicker. And we're going to stick with 50 milliliters because it's easier for us to do our math that way. So I filled our graduated cylinders. We have exactly 50 milliliters in each one. We're only going to be doing one at a time, so I'll set this one aside. Our next step, it says break and mold this clay into 3 separate spheres. So I'm just going to rip him apart and make 3 little spheres of clay. When we're doing so, we got to make sure that they fit inside the graduated cylinder. They've got to be able to sink to the bottom so that we can get an accurate measurement of the volume. Now, this is the same piece of clay that we used for test 1. I haven't done anything other than change it by ripping it into 3 equal or somewhat equal sized spheres. Step 14 says lower all 3 spheres into the graduated cylinder. So we're going to drop each of the spheres in there, all the way down to the bottom, all the way down, and all the way down. Now, all 3 spheres are in this. Test 2, trial 1, with 3 spheres. You can see them in the bottom, and we have 63 milliliters. So you saw that we had 63 milliliters. I'm going to dump this out. Get our clay spheres out. So although we're not using a cylinder on trial 2, we got the same results. Make sure you record that in your data table. You started with 50 milliliters of water. It went up to 63 milliliters with the 3 spheres. Now we're going to repeat steps 13 through 17. So we've got another 50 milliliters of water. We're going to drop our 3 same spheres in. Test 2, trial 2. There's our 3 spheres in the bottom, and we are at 61 to 63 milliliters. So again, nothing has changed. So now that we've recorded our data for trial 2, I'm going to dump out our spheres in our water, and we're going to do our final trial. Again, 63 milliliters. Record that information in your data table and then move on to the third and final page of the lab. The third and final page has a bar graph for the clay volume. So you have shape 1, and you're going to do your 3 trials and the values that you got from test 1. Then shape 2 is when we took the cylinder and turned it into 3 spheres. You're going to create a bar graph using your values for the 3 trials you did there. So after you finish your bar graphs, move down to the analysis. There are 2 analysis questions. Describe what your data tables and your graph tells you. And number 2, discuss how this proves or disproves your hypothesis. So we've gone through the how constant is volume lab, and hopefully by watching this, you can answer this problem. Will the volume of a piece of clay change if its shape is changed? Thanks guys, and I will see you again soon.